We're given this recursive function. The first value in the sequence is always 0. For any value after that, for k greater than 1, the kth value depends on the previous value. I add 1 to the previous value and multiply that quantity by 2. What I want to do is find the sum of these from k goes to a to b. So I need to calculate all of these up to k equals b and then add the ones that are between a and b for k here. For a programming problem, what I'll usually do first is give myself an example. So suppose I choose a equal to 3 and b equal to 5. Let's see what I'd get if I calculated this by hand so that I can examine what's going on before I start trying to write a program to do it. First, I always set f of 1 equal to 0, because I always need the value at 1 before I can calculate the value when k equals 2 and so forth. It always depends on the previous value. Starting at f equals 2, f of 2 is going to be 2 times 1 plus f1, which is 0, which is equal to 2. So for k equal to 2, I start using my equation. And for any subsequent k, I'll still keep using this equation. When k is equal to 3, f of 3 is 2 times 1 plus f of 2. So 2 times 1 plus 2 is 2 times 3, which is equal to 6. When k equals 4, f of 4 is 2 times 1 plus the previous value, which is 6. 6 plus 1 is 7. 2 times 7 is 14. For k equals 5, f5 is 2 times 1 plus the previous value, which is 14. 2 times 15 is equal to 30. Now, k has gotten to be equal to b. I don't need any later values in order to calculate my summation. So I'll stop when k is equal to b. Now I need to add the terms. I need to add, since a is equal to 3, I start adding at f3 plus f4 plus f sub 5. So I start adding when k is equal to a. I end my summation when k is equal to b. So taking my values, this is 6 plus 14 plus 30. So my summation from k equals 3 to 5 of f of k is equal to 20 plus 30 is 50. Now I have an answer to shoot for if I plug these numbers into whatever algorithm I come up with, and if it doesn't give me 50, I know I have a problem. After I've gone through an example, I'll probably create some pseudocode, which is really just a list of the steps in kind of a combination of MATLAB Ease and English that I went through when I did my example. So the first thing I did was to set a and b. We need to know where we're going to start and finish our summation. Second, I'm going to need to set my first value. The first element in the sequence is always 0. Now I'm going to start looping through all the elements up to b. So I'm going to use a for loop because I know how many times I'm going to use it. K starts at 2, 3, 4, ... on up to b. So the kth element of the sequence, f sub k, is 2 times 1 plus the previous element in the sequence, fk minus 1. Now I need to make a decision in order to decide where to start adding things up. I started adding when k got to be equal to a. So if k is greater than or equal to a, I start keeping track of a summation. So I'll set a value sum is equal to sum, the previous value, plus whatever f sub k is. Then I'll continue to the next element. Go back up to here. Now I do have a problem in that the first time I do this, I won't have a previous value for sum. So up here, I'll also need to initialize sum to be 0. Now let's convert this to MATLAB. To set a and b, to do my example, I'll set a equal to 3, b equal to 5, f, the subscripts are going to become elements in an array for me in MATLAB, so f of 1 is equal to 0, and sum is equal to 0. Now this, I've built in the fact that I'm going to use a for loop. So for k, starting at 2 and ending at b and counting by ones, that's the syntax. Now the kth element in this array is going to be f of k is equal to 2 times 1 plus f of the previous element in the array, k minus 1. Now I'm going to put my decision in there. If k is greater than or equal to a, sum is equal to sum plus f of k. I can end my if statement and I'll end my for loop. And that looks like it'll do what I've outlined in my pseudocode. So I still need to create this as a function. But what I'll do when I'm doing this is probably create this as a script file without the function declaration statement, make sure that it actually works, that it gives me the same answer I got before, and then I'll add the function statement and modify the code as necessary. So let's go over to MATLAB. Here's my script file. It's named myfun.m and it contains the same statements that I had previously on my slide. Now let's go over here to the MATLAB command window and run this and see what we get. So myfun creates the vector f 0, 2, 6, 14, and 30, which are the same elements in the f array that I got before, and it added up these three. 6 and 14 is 20, 20 and 30 is 50. It's working just fine. Now let's go back and make this a function. In order to create a function, I need a function declaration statement. So I'm going to add a line up at the top that starts with the word function. Square brackets, what's getting returned, which is just the sum of these values. An assignment operator, and I'll call this myfun of a comma b. Now the values of a and b get set in the function declaration statement. They're sent to the function, so I better not reassign those here. So now a and b get sent. It initializes f of 1, initializes the sum, does this. I don't think I really want to see these displayed anymore, and I don't really need to see the sum displayed anymore. Now I'll save this, go back to the command window, and run it as a function. So I'm going to say myfun of 3, 5, and the answer is 50. Works just fine, meets the specifications. I'm done.